Hey gang, so this is the Payload concept proposal preparation video. Basically, I've just pulled the Payload concept proposal template up here on the screen. We're going to go through it and talk about it. So I know you can't read this, so please look at your Payload concept proposal template as you go along with this video. I'll try to keep this brief. It's just pretty much the PCP describes what you should have in it. Now remember, the PCP is the first thing that is scored. It's worth 20% of the total, so make sure you do this properly. So the first thing that we see here on the PCP is the title page. Gotta have a title page. Must have a title page. You are graded on whether, you are evaluated on whether you have a title page. Keep the title page in there. This title page is one of the Word standard title pages. If you don't like it, you can change it, but put a title page in there, okay? Make it your own. I'm going to get up on this table here so I can do this better. So put your team name in here, your high school in there. You might want to put your team number in there as well. That helps out the UAH people because they evaluate you based on team number. Scroll down, keep the title page please. And introduction. Provide an introduction to your paper here. Introduce the reader to the name of your payload if you have one. So this is kind of a summary of an overall, hi, we're team so-and-so, we're from so-and-so high school. Is it a physics class? Is it an engineering class? Is it a chemistry class? Tell us about your, give us a very brief intro on your payload. Keep it brief because you only have 8 pages, okay? And you need those 8 pages. But you want to introduce the reader to your team and to your payload. So that when you start bringing things up, then they get it. Okay. Usually the intro you write it in the beginning and then you go back and rewrite it in the end because you've written the rest of the paper. That's what I typically do. Is I write some ideas down for the intro, then I go back and change those once I figured out what I want to write for the intro. Part 2, science objective instrumentation. This should be a no-brainer. This should be what you guys have done all semester. Discuss your science objective here. Provide the rationale as to why this objective is important. Who cares? Why is this objective important? That's what you want to hit on here. You want to put commentary in here. Too many teams just put stuff in the tables and they do not put any commentary. You want to explain things in the paragraphs, okay? Discuss what measurements are needed for the science objective. How are you going to accomplish this science objective? Provide as much detail as possible about the method that you've chosen to make these measurements. Remember to complete the science traceability matrix in table 1 below. Table 2 is the instrument requirements. And then I think there's a table 3. Table 3 is the support equipment table. So fill in those tables. You've done this all semester. We've seen this. Fill it in, the information in. And remember, if it says power in watts, don't put the wattage in there. Keep the units proper. Keep the units correct. Have everything centered or right justified or left justified. Keep everything consistent in there in the tables. You have to discuss, if you have a table or a figure in your paper, you have to introduce that table or figure in the text somewhere and somehow. If you just say, our team science traceability matrix can be found in table 1, and then you explain how you walk through the science traceability matrix. You explain, okay, our overall objective is this. In order to accomplish this objective, we plan to measure these things. These measurements require these types of requirements. And these measurements can be accomplished with these instruments. The instruments can be found in table 2 in the instrument requirements table. Then you say, the IMU takes, has so much mass, has so much power, requires so much power, creates so much data, and then the commentary is where you feel is really where the mass and the power and the data rate, that's in the table. They can read that. The commentary is where you want to talk about these things. Why are you using your instruments the way you're using them? Why are you turning them off and on? Why are they being on continuously? Okay, that's where you use the commentary. That's where you use the paragraph above, or you could put more paragraphs in here too. That's where the commentary comes in, is explain why you're using the instrument the way you're using it, okay? Explain that in the paragraph and then refer to the table for the numbers. Does that make sense? Okay, good. Support equipment, it's the same thing for support equipment. The mass and the power they can read from the table, the component, but then other technical specifications explain why the support equipment is necessary. Why do you have to have a processor? Why do you need a transmitter? Why do you need an antenna? You know, are there any special specifications that you looked at? Any special, you know, if you've got a, why did you choose the processor you chose? If you chose it from the Inspire's notebook, that's fine. It's a low power processor, you know, stuff like that. That processor is actually from a CubeSat. Look at if you chose it from the Inspire's notebook, look at the Inspire's notebook to where that instrument was found, or where, because all the instruments are real. And if it's a CubeSat instrument, list that. Say it's a CubeSat instrument. It has heritage, means that it's flown in space before. That's a big deal for space missions. You can't forget about the commentary. You can't forget about the paragraphs when you have tables. People tend to do that. They just put a table in there and they just say, "There's your table. Read it." No. Why is that table? Why is the information in that table important? Tell me why it's important. Okay. Payload design requirements, section 3.0. Provide the requirements that you have developed so far. Hopefully, since this is the PCP, you got your requirements down pat. Okay. So remember, there's 4 major types of requirements. There's project requirements, and then the project requirements, they sort of dictate the environmental requirements, the functional requirements, and then the science requirements, which we just talked about. So science requirements, they're done. Talk to us about project, environmental, and functional requirements. That's what you talk about in here. And you can have subsections if you want. You can have 3.1, 3.2, 3.3 if you want to talk about the different types of requirements, project, functional, and environmental. You can talk about that way. It helps the reader out. So you can have subsections. Just because it's not here doesn't mean you can't have it. Okay. So section 4.0, alternative concepts. Describe the 2 concepts that have been developed. Describe, that means use sentences, words, sentences. You want to have pictures. You want to have nice images, nicely drawn, hand-drawn images at the very least. Nicely hand-drawn images. CAD images at the best, or you can have like a PowerPoint drawing or a Word drawing in there if you want. But you have to show us what your payload is in some way and describe it. You know, this picture, people look at a picture and they go, "Oh, I don't get it. I don't understand what I'm looking at here." Describe what they're looking at, okay? Like you would describe it in words when you're presenting it, describe it in words here, okay? You got lots of space. Use the space. Decision analysis. We have, hopefully, I'm recording this before the DA, before the decision analysis review. Hopefully we hammer home how important decision analysis is. But you need to explain your figures of merit, explain their definition, explain why they're important, explain why you weighted the FOMs the way you weighted them, explain why you scored certain things the way you scored them, explain what group 1 and group 2 are. Give them names is the better way to do it. Give them the names that you gave them above. Give them names. And then you need a total here at the bottom, so I don't want to do math. Put a total at the bottom and tell us who won. Make sure you tell us who won and why. And then, again, a decision analysis is just a communication tool. So if you want to use there's a PowerPoint presentation that went with the decision analysis video. If you want to use a table for MIT, you can use a table for MIT. You can use this table if you want, whatever. But you want to make sure that you explain your decision analysis well, okay? And explain that you were limited to 1, 3, and 9 for your choices, for weights and for scores. Explain that. So that the reader doesn't ask questions about why are they using 1, 3, and 9? Why are they using 10? Why are they using 4? Stuff like that. So, engineering analysis. Describe the analysis that you conducted on your final design. Include any figures that will help this discussion. I know one figure that will be a big help. A flow chart. Flow chart will be helpful with the engineering analysis. That's extremely helpful. And the flow chart can be boxes with text inside the boxes, or it can be pictures. There's the design team should have watched the introductory video that I did, so I know what's on it. The introductory video to your engineering analysis talks about flowcharts. This would be a great place for an engineering analysis flowchart. But walk us through the flowchart. Don't just put a flowchart in there and say, "But done." Walk us through the flowchart. Explain the different boxes of the flowchart, okay? Again, you can put a few equations in there. If you use an equation several times, you can put an equation in there and this. But limit your equations. They're going to assume you got the equations right and tell us the final answers. Final design. Describe the final design here with all its key points and concept of operations. ConOps in this is very important. ConOps is important. Explain the ConOps, your final design. Provide a sketch of the payload, a sketch at the very least, a a engineering drawing would be nice, or a PowerPoint drawing would be nice. Also provide the data in table 1. Here's your mass by functions, okay? How are you deploying, okay? What do you use to deploy? That includes, if you have a barrel for deployment, that includes the barrel. It doesn't include the mass for the helium or the mass for the plumbing for the helium. What's the mass of the barrel that you're using to deploy? What's the measurement mass? What is the sum of all the stuff you're using to measure? The sum, what is the mass spec? What is with the thermocouples, with the pressure transducer? What is the sum of all the measurement devices? Put that here, okay? You can put another column in here that explains what these masses are. You know, you can put thermocouple plus IMU plus mass spec plus pressure transducer equals all these masses here, okay? Collecting the data. That's your data storage. What is your data storage device? How much does it, you know, what is the mass of it? Explain what that is. Provide power. What is the mass of your batteries? There's a video on power, on how to calculate battery mass for your payload. Your team should know that. Sending the data, what is the transmitter and the antenna mass? And containing and housing, what is the structure mass? You can also include under collecting data, it could be your processor as well, because your processor was required to collect data. The mass, you should total all this up and put a total at the bottom here. It's not in this table, but to put total at the bottom. This total should match your total mass. So everything should be accounted for. Basically what this table is saying is that all the masses that you have provide a certain function. That's what this is showing, that all the masses that you listed up here, it's the same masses that you listed up here. The same masses that you listed in this area here. You got your science, your instruments, your components, same masses, but they all provide a function. That's what this is showing, that all the masses provide a function, and then they total at the same mass. Better be the same mass. Payload design compliance. So this is basically check boxes. We meet it, check. We have, this is 10 kilograms for this semester. No more than 10 kilograms of mass, check. Our mass is 9.8 kilograms, whatever. We fit inside the box, check. If you have a waiver, you can put parenthetically waiver, with waiver. You can put that if you want to. Survive the environment, check. We know we'll survive the environment because of our structure, because of our insulation, whatever. No harm to the spacecraft, check, because we're going to deploy out with helium, no bangs and no booms. So for each of these check boxes, explain why it's a check. You'll have a paragraph above the table or below the table, whatever, explaining why there's a checkbox there. Explain the checks. Just like you will have a paragraph that explains the masses in this, explains what these, the deployment consists of a barrel, consists of, if you have certain parts of your structure or part of the, what constitutes deployment, and what that, explain the table and explain, there's the figure here, the figure of the final design, explain the final design. Tell us what makes it, why is it cool? Why did you design it the way you designed it? Explain it in the text. And then last, but certainly not least, is CEA. Section 8.0 is Community Engagement Summary. Summarize your CEA. If you have any pages left over, and again, this is just, you've summarized your CEA in a bunch of presentations so far. Give us the overall stats that you have. Give us the total number of visitors you had, the breakdown of male, female, and the breakdown of grades that we asked for, the grade distribution. Give us that in this. You can put a table in there. You can put some bar charts or pie charts or whatever. Pictures. You should have a ton of pictures in this. Pictures of cute kids learning science. That's what you want to do in this section. You should not have any pages left over because you just fill those pages with pictures from your CEA events, okay? That should be it. This is a real quick one. Write this early and write it and then edit it often, okay? I'm going to exit this out and just talk to you guys. The payload concept proposal, write it early. Get it done early. Send it to your UAH PM. Have your PM mark it up and send it back to you. Have your teacher mark it up and send it back. Have your English teacher mark it up and send it back. Have your parents read it and say, this doesn't make any sense. Write it early, get lots of opinions on it, and then keep editing, keep correcting. That's the way to do this. That's the way to make good papers. Do this. You can go online on the inspires.org website and look at the archives page if you want to look at examples of previous papers that did well. We changed the length requirement on the paper like a year ago, so some of the papers might be 5 pages, but I think last year we had 8 pages, so you can look at the last year's papers to get papers that are the same length as your paper. So especially the spring 2014, that's when we had I think we had longer papers in spring 2014 when they had the CEA events. So again, write it early, write it, and then edit it often. That's the way to have a good paper. Basically, that's what it amounts to. So if you have any questions, if you want us to read it or your UHPM to read it, let us know and send it to us, and we will do that. But that's about it. I wanted to keep this video short. The template kind of speaks for itself. It's basically like the PSR, but bigger. Thanks a lot. Bye-bye.